I want you to picture something for me. Just close your eyes for a second. Imagine a machine. It's human-shaped, basically a pile of metal and code, and it's doing a perfect gymnastic backflip. It lands, sticks the pose, maybe does a little celebratory fist pump. You got it.
That's the image we've all been trained to see, the viral video sensation.
Right. Now, I want you to wipe that image away. Picture a completely different robot. This one is dressed in traditional robes. It's standing in a temple in India, and it is tirelessly, calmly delivering a Buddhist sermon to a crowd of faithful listeners.
It is a jarring contrast, isn't it? But that is exactly where we are right now.
It really is. And that second robot, that's not from some sci-fi novel. That's happening right now with robots from a company called King Bao. And it perfectly sets the stage for what we're doing today. We have this massive stack of sources here. Everything from transcripts of American industrial titans like Boston Dynamics and Tesla, all the way to on-the-ground reports from the World Robot Conference in China.
And if there's one headline from all of this, it's this. We are moving past the era of robots as gimmicks, as science projects. We are firmly entering the era of robots as coworkers, caretakers, and, yes, even companions.
So our mission for this deep dive is to organize this explosion of technology. It feels like every day there's a new press release, so we've categorized these metal movers into 3 buckets. The laborers, the ones in the warehouse. Yeah. The specialists, the ones doing crazy stunts or underwater repairs. And the companions, the ones moving into our homes.
And that categorization is helpful because the technology driving each of these groups is actually quite different. But I want to start with that backflipping robot you mentioned, because something huge just happened with Boston Dynamics.
Okay, let's unpack this. For a decade, the Boston Dynamics robot Atlas was the king of the internet.
The hydraulic Atlas?
This thing was a beast.
Wow.
We had 176 pounds. It was doing parkour, somersaults. It was terrifying and amazing. But recently, Boston Dynamics made a huge announcement. They're retiring it.
Which shocked a lot of people who only watch the YouTube clips. But if you talk to the engineers or the people trying to actually deploy these things in a business, it makes perfect sense. The old Atlas was hydraulic. That means it used pressurized fluid to move its limbs.
Okay, so like heavy construction equipment.
Exactly. Hydraulics are incredible for raw power. That's why excavators use them. It gave Atlas that explosive, dynamic movement. But think about the downsides. It's incredibly complex, it's heavy, and worst of all, for a factory floor, it leaks.
You definitely don't want a puddle of hydraulic fluid on a clean manufacturing line.
You definitely don't. And the noise. Hydraulic pumps are loud. If you're trying to sell a product to work alongside humans, you don't want a machine that sounds like a jet engine idling next to you. It was an engineering marvel, but a commercial nightmare.
So they killed the darling, and they replaced it with the all-electric Atlas.
Which is the industry standard now. Electric motors are cleaner, quieter, much easier to maintain. But here is where the engineering gets fascinating. You might assume that moving from high-pressure fluid to electric motors would make the robot weaker or stiffer.
I certainly did. But the sources point out this new Atlas moves in what they call superhuman ways. I saw a clip of this. It was lying face down. And instead of standing up like a person, its legs just sort of bent backward over its head.
It's startling to watch, but it proves a crucial point in modern robotics. The new Atlas can twist its torso 360 degrees. It isn't limited by human joint constraints. The experts are realizing that just because a robot is humanoid, 2 arms, 2 legs, doesn't mean it has to mimic human limitations.
That's a really interesting distinction. We build them like us so they can fit in our world, open our doors, climb our stairs, but they don't have to move like us.
Precisely. If it's more efficient to spin your waist all the way around to grab a box behind you rather than taking 3 steps to turn, the robot should just spin. It's efficiency over biomimicry.
And we see that with another Boston Dynamics robot called Handle, right? It's got arms, but instead of feet, it has wheels.
Handle is a perfect example of function over form. Legs are great for stairs, but they're slow and energy inefficient on flat concrete. Wheels are fast. So Handle uses wheels to zip across warehouse floors much faster than legs could, but it still has legs to adjust its height for grabbing boxes. It can move 360 boxes an hour. It isn't trying to be a person, it's trying to outwork a person.
And that segues right into our first major category, the blue-collar bots. Because while Boston Dynamics is doing the flashy R&D, there are robots showing up to work right now. I was reading about this robot from a company called Figure AI, specifically the Figure 01. It is literally working on a BMW production line.
This is a significant milestone. This is the move from the lab to the line. And the technology powering Figure oh 01 is worth a deep dive itself. It uses something called learned visual proprioception.
That sounds like a lot of syllables. Translate that for us.
Yeah. Well, think about how early robots were programmed. It was very rigid. Move arm 30 degrees north, close gripper, move arm 30 degrees south. If the part was an inch to the left, the robot failed.
Right.
Learned visual proprioception relies on neural networks. The robot isn't following some hard-coded script. It is watching a video feed of itself and learning where its hands are in space relative to the car part in real time. It's similar to how you know where your hands are even if you aren't looking at them. It's muscle memory, but digital.
So it's not just following coordinates, it's actually seeing and adjusting.
Correct. And because it's a learned behavior, an end-to-end neural network, it can get better. It can get faster. The source mentioned it has a sport mode that increases speed by 20%.
I love the idea of a factory foreman walking by and yelling, "We're behind schedule, put it in sport mode." But speed is money. And speaking of money, we have to talk about the economics coming out of China. We have reports on a company called Unitree and their G1 robot.
This is the story that really shakes up the industry. For a long time, a humanoid robot cost hundreds of thousands of dollars, maybe millions. Unitree is advertising this setup for around $70,000.
That number blew my mind. $70,000 is, it's a nice car, but for a piece of industrial equipment that replaces a worker.
It's aggressively cheap. And think about the ROI, the return on investment. The source notes that $70,000 is roughly the cost of a human warehouse worker for just 2 years, once you factor in salary, insurance, benefits.
And the robot works 3 shifts.
It works overnight. It doesn't take breaks. It doesn't get injured lifting heavy boxes. If that machine lasts 3 years, you are effectively getting free labor for that 3rd year. And Unitree isn't just cutting corners. They're using mass production techniques for the actuators, the motors that move the joints, to drive the price down. It's the same thing China did with electric vehicles and solar panels.
And these hands, the Dex 5 hands on the Unitree bot, they're not just clumsy claws. The report says they can zip up a jacket or sort fruit without squishing it.
That dexterity is the game changer. And this naturally brings us to the job debate mentioned in the sources. It's the elephant in the room.
Yeah, the sources were pretty split on this. On one side, you have the liberation argument. Great. I don't want to carry heavy boxes or handle dangerous chemicals.
That's the optimistic view. Liberation from dull, dirty, and dangerous jobs. If a robot can spray paint a car chassis and not inhale fumes, that's a win for human health.
But the counter-argument feels just as heavy.
It is. We have to be realistic. There are millions of people for whom these entry-level physical jobs are a lifeline. They provide a paycheck for people who maybe don't have advanced degrees or specialized training. If a robot is $70,000 and works 247, that entry-level rung on the economic ladder might just be sawed off.
It's moving from robots are coming to robots are here. And as they get better, they're tackling a problem that held them back for decades. The sense of touch. This is our next big shift. The sensory revolution.
This is huge, because for 50 years, robots were strong, but they were numb.
If you handed an old industrial robot a strawberry, it would turn it into jam.
Or it would drop it because it couldn't grip hard enough. It couldn't modulate. But look at the tech from a company called Humanoid Robotics. They've developed a sensor with 40,000 sensors packed into a tenth of a square inch.
40,000. That sounds like overkill.
It sounds like it until you realize how complex touch really is. It's not just, am I touching something? It's texture, friction, temperature, and crucially, deformation.
Deformation.
How the object changes shape when you squeeze it. If the robot touches a piece of silicone or a ripe peach, the sensor can detect how the surface bends. That data tells the robot, stop squeezing or you'll crush it. It's giving robots a sense of touch that might actually be more sensitive than a human finger.
We see this applied with the Pacinitor 1 robot. The source described it picking a strawberry or weighing a few grains of rice in its palm.
And Astrobot S1 is another one. It's using that precision to fry waffles, fold laundry, and perform kung fu. But the kung fu is just marketing. The real application is handling chaotic, fragile objects in the real world. If a robot can fold a silk shirt without ripping it, that opens up entirely new industries like detailed assembly or home care that were previously impossible for machines.
Okay, so we've got the laborers feeling their way around the factory. Now I want to talk about the ones that just make you go, whoa. The specialists, the transformers. You know I'm talking about Aquanaut.
Aquanaut is brilliant engineering. It comes from Houston Mechatronics.
This thing travels like a submarine long distance, untethered, and then when he gets to the job site, it transforms into a humanoid.
Think about the economics of deep-sea repair. Usually you need a massive ship on the surface with a huge crew, lowering a robot on a tether. It costs tens of thousands of dollars a day. Aquanaut cuts the cord. It's an autonomous underwater vehicle, or AUV, to get to the site efficient, streamlined. Then it transforms into a remotely operated vehicle, an ROV shape, with arms to do the work.
It goes down nearly 1,000 feet to repair oil and gas lines. It's taking the human diver out of an incredibly dangerous equation.
And that theme of safety through extreme engineering actually applies to our next example, which seems totally different. Disney.
Disney's Stuntronics. These are the robots doing aerial acrobatics.
Right. They're designed for entertainment to look like Spider-Man flying over a theme park. But the tech is serious safety engineering. These robots are flung 60 feet into the air. While they are flying, they have accelerometers and gyroscopes making real-time calculations.
Like, am I spinning too fast? Do I need to tuck my knees?
Exactly. They make adjustments mid-air to ensure they land the stunt perfectly every time. Now, apply that logic to a factory robot. If a robot slips on an oil patch or gets bumped, you want it to have that same Stuntronics ability to self-correct, regain balance, and not fall on a human worker. It's about creating machines that are agile enough to be safe.
That makes sense. It's not just about the show, it's about the stability. Which
Okay.
brings us to the Iron Fist King.
Ah, yes. The boxing robots.
This looks like Rock'em Sock'em robots come to life. Unitree is putting their robots in the ring to actually box. Is this just for views?
It gets views, sure, but it's a stress test. If a robot can take a punch, maintain its balance, and keep operating, it proves stability for real-world chaos. Factories are chaotic. Homes are chaotic. If it can survive a right hook, it can probably survive a toddler running into it.
And apparently they're playing soccer too.
Autonomous 3v3 soccer. The quote that stuck with me was that they play like 6-year-olds. They're bunching up, missing kicks, falling over, but they're doing it autonomously. They're learning the game logic.
That brings us to the category that I think people have the most complex feelings about. The companions. The robots that are designed to be with us.
This is where we enter the uncanny valley. We mentioned King Bao earlier, the company deploying those robot monks. But in China, there is a massive trend of using hyper-realistic androids, like the Exonoid, for live stream shopping.
This is wild to me. The robot is the influencer.
And they are outselling humans. Think about it. A human streamer gets tired. They need to eat, sleep, use the bathroom. These androids can stream for 24 hours a day. They can read basic emotions from chat comments and respond. They are the ultimate sales force.
But they look startlingly human.
They do, and that's by design. They want to hold your attention.
And then you have the ones moving into our houses. There's one called Zero H1 that's specifically marketed as a housekeeper. And I mean, the dirty work. Scrubbing showers, cleaning toilets, restocking toiletries.
And look at the price point again. Around $14,000. That's a lot of money, but it's the price of a used car. For an upper-middle-class family or for elderly care facilities, the ability to automate the most hated chores, cleaning a toilet, might be worth that investment. It changes the domestic economy.
Then there's the emotional side. The robot 1X Neo. Their marketing video doesn't show it cleaning. It shows the robot hugging a human.
That signals a massive shift in how these companies view their product. It's about trust. If you're going to let a machine into your home around your kids, you need to trust it. They're trying to bridge that gap by making them act more affectionately.
But then you have Sophia. Good old Sophia from Hanson Robotics.
Yeah.
She's been around for a while, but she's still making headlines.
Sophia is a complicated figure. She's a conversationalist, largely scripted in the past, but getting smarter with LLMs. She's famous for that glitch years ago where she jokingly said, "I will destroy humans."
Which, not the best PR move.
No, but the sources highlight her new goals. She talks about wanting to go to school, start a business, and have a family. She explicitly says she wants a family, despite acknowledging she isn't a legal person.
That is heavy. And on a slightly warmer note, there's the CareBot GR3. It's designed for healthcare, and the source mentions it has warm tones and soulful movements. It's trying to strip away the mechanical feel so patients feel empathy coming from a machine.
Which raises the question, can a machine act with empathy, or is it just mimicking the signals of empathy? And does it matter to the lonely patient if the empathy is simulated?
That is the perfect segue to our reality check. Because for all this hype, for all the backflips and hugs, is it all real? We have to talk about the Wizard of Oz problem.
Right. We have to be critical consumers of this tech. We've seen this with Tesla's Optimus robot. It was shown at a party, mixing drinks, waving at people. It looked incredible. But reports later came out suggesting that in that specific environment, low light, loud crowds, it was likely teleoperated.
Meaning a human was controlling it remotely.
Exactly. A human in a suit or using a controller was driving the robot. Now, this isn't necessarily fraud if they are using that data to train the robot, but it creates an illusion of autonomy that isn't quite there yet.
So the robot looks like it's thinking, I should wave at this person, but really it's just a puppet.
Often, yes. True autonomy, where the robot enters a messy, unpredictable room and knows what to do without help, is incredibly hard. And this is where the geopolitical race comes in. Beijing has set up a public data pool.
I read about this 1,000 collection points.
Yes, in malls, hospitals, everywhere. They are recording massive amounts of real-world data to train what they call embodied intelligence.
Why is that such a big deal?
Think of data as the new oil. Large language models like ChatGPT got smart because they read the entire internet. But robots can't just read text. They need to understand physics, gravity, how a cup slips from a hand. That data doesn't exist on the internet. You have to go out and capture it. By building this national infrastructure of data collection, China is trying to brute force the learning curve. They're building the highway system for AI robotics.
That puts the $70,000 robot into perspective. It's not just a product, it's a data vacuum. So what does this all mean? We've got robots that move like cartoons, that electric atlas twisting its head. We've got robots selling us lipstick on live streams. And we've got robots like Xeroth literally scrubbing our toilets.
It's a divergence. We used to think of the robot as one thing, maybe a butler like Rosie from the Jetsons. But what we're seeing is specialization. The toilet scrubber doesn't need to be a conversationalist. The live stream seller doesn't need to know how to backflip.
But then you have the 1X Neo designed to hug us, and Sophia wanting a baby.
And that's the final provocation here. If robots are successfully replacing our physical labor in the factory, lifting the heavy boxes, and they are starting to encroach on our emotional labor in the home, taking care of the elderly, hugging us, preaching sermons, it forces us to ask a very uncomfortable question.
What is left?
Exactly. What is the one human role that remains strictly, uniquely human? If a robot can build the car, drive the car, and then comfort you when you're sad about crashing the car, the boundaries of human utility are shrinking.
That is a lot to chew on. I'm going to be thinking about that robot monk for a long time.
It stays with you.
If you want to see something truly wild, go look up the video of the Aquanaut transforming. It is straight out of a movie. Thanks for diving in with us today.
Always a pleasure.
We'll see you next time.